Welcome, everyone. Thanks, Sophie and Vincent, for giving me the opportunity to talk to you here today. I want to introduce a project or an approach that I've been working with Maximilian Moses, who's at UCL in London, and I'm currently in Tilburg and at UCL, which is about chat-based information elicitation. And I'll not focus that much on machine learning classification, which I'll touch upon this, but I think the overall bigger picture and development of how we did this might be more interesting here today. Okay, so now, what is the aim of this project and what are we talking about? Now, there is this very famous paper by Aldo Frey and Per Garner called Eliciting Cues to Deception. What matters are the questions asked. And there's been this very dominant paradigm in deception detection built on investigative interviewing. Now, if we then move to this large scale context, talking about, let's say, airport security screening or border control, then we inevitably face this issue that this whole idea of asking good questions becomes more difficult, right? Because how will you scale this up? You could say, well, we do this with individual border patrol agents, but that quickly becomes inscalable. So then the automated approaches to verbal deception detections, where you're interested in analyzing what's the information that someone is giving you, typically resort, and we have done this in the past, and others have done this as well, to asking participants online to write a statement that is then either truthful or deceptive, and then you use some analytical techniques to make a decision. Now, but that has a problem, because what we're missing there is this whole interaction between an interviewer and an interviewee, right? And if we look at the literature, we see, well, this is quite important, but the automated approaches really lack this. So we started with this project where we wanted to fix it and really wanted to harmonize what we can do with automated methods inspired by machine learning and natural language processing, and how we can bring these together with what we know from cognitive interviewing and this idea. Now, we had a set of criteria that we wanted to fulfill here. So we wanted to have a system that is adaptive. So that means it should be able to ask questions. A system should be able to automatically ask questions in a sort of chat interface, but should do this in a unique flow. So that means no single conversation will ever be the same. It should be dynamic, so it should be very brief interactions like you would do in a WhatsApp chat with someone. Should be active, so the system should say, I actively want to elicit information from the interviewee rather than waiting for useful information, what we typically do with asking people to write a full statement, where we just hope that they give you useful stuff to work with. And it should be calibrated. And what we mean with this is it should ask questions that have a high information gain, so questions that are actually useful. Now, for us, the question was how can we do this? Now, what we started with is we mapped out what a desirable chat flow would look like. So here's a brief example. So this is what we would hope to achieve in an automated system. Right, there will be a question, and here we use the context of intentions. And because we couldn't really work with people's activities due to the whole lockdown measures that were in place, we created the scenario. We asked people, what's the first thing, so they have a clear intention, what you'll do when the pandemic is over, when life goes back to normal, what's the first thing you'll do? Now, an interview would then ideally look like this. So what would be the first thing you'll do? The interviewee here indicated with an A for answer says, I'll rebook a holiday we had planned for 2020. Then follow-up question, any special places in mind? Kenya and Nairobi. What are you looking forward to when you get on holiday, etc.? So this is the kind of stuff we would look for to realize this in an automated manner. Now, our approach to this was initially that we said, okay, we'll just use existing chatbot systems and fine-tune them a little bit. Now, but this brings a problem that chatbots, as they are out there, and many of us have encountered them. For example, if you order pizza, you will typically talk to chatbot if you do this online. Now, the problem with this is that we're talking there about a system that detects so-called user intents. Right? So there, the task of the chatbot is to identify what does the user want from me. Right? That's if you have a service-facing or service-focused chatbot. But in our case, we didn't really want this. We didn't really want to identify what let's say, a participant that is instructed to either lie or tell the truth wants. But what we want is we want a system that has intentions, and the system has the intention or the intent to find out whether this person is lying or not. So the system has a goal. That's the difference. So that meant we had to start from scratch and build a system from zero, really. And I'll walk you through how we did this in the next few slides. Now, broadly, our approach can be characterized as follows. We call it system intents and information silo fulfillment approach. Now, the system intents part means that the system, so the system is the chat bot system that we built, has an active goal-directed behavior. So the system has a goal, and the goal is to elicit useful information. Right? Now, this adheres to this flipped logic, as I said, right? It's not user intents. We're not trying to figure out, do you want to order margarita with double cheese, right? That's user intents. The system is here to find out a specific piece of information. Now, the other part is the information silo fulfillment. And the aim here is that the system says, well, there are certain, what you see here in the image on top, there are certain silos, what we call them, of information. For example, characterized here as the what, where, when, who questions. And every time a participant answers a question, that information is allocated to one of these silos, so it's classified. And we use machine learning to do this, but that's not really the difficult part. So essentially, every piece of information is allocated, and the system determines, oh, this was about what the person is doing, and that was about who the person is doing it with. And then you can see how this could work out, because you can then fine-tune your system and say, okay, I'm actually interested in a lot of the who, a bit of the what, a lot of the where, and a bit of the when, and then sort of say, okay, if you reach this state as a system, you end the conversation. Now, because we're talking about we're here at the Deception forum, I'll walk you through how we developed everything. But there was one very tiny lie that I made at the beginning, because this flow that you see here is actually from our automated system. Right? So this is not written by a human, the question. The answers are from a human participant. All the questions are from our system self-chosen without any interference from us. So this is a system that has learned to ask questions and has learned to follow up on questions and try to elicit information. And I'll now walk you through how we develop this, and I'll show you then a few results, especially on the deception part. These are sort of development of system briefly, then feedback learning studies, quality evaluation, and then deception studies. Now, system development, how did we go about that? So our scenario was intentions. Ideally, with sort of next weekend activities or scenarios like that. Didn't work, so we had to flip to a post-corona scenario, and really we're asking people, well, what's the first thing you'll do after the pandemic is over? And we had to generate an initial set of questions and answers that you would call good question and answers, or good conversations. Now, the way we did this is we developed a sort of self-chat paradigm where people played a game with themselves. We were first skeptical whether this worked, but where they played a game with themselves and said, okay, interview yourself and try to figure out what you will do after the pandemic's over. So no deception involved here. It's just for us to have a seed corpus of questions and answers to work with. Now we did this, and this resulted in 15,000 question answer pairs. Now in the next stage, we then asked participants independent from the first phase and label each answer that was given. Right? So we asked for every answer, we said, okay, here's a piece of information that someone gave. What does this refer to? Does this belong to what, to who, to when? So these information silos, so that we could then use this to train a system that learns how to allocate answers into these information silo slits. And then based on that, we devised a question selection algorithm that essentially looks at the state of the system, looked at the context of the answers that were given, and then finds the next question that is most suitable given the whole flow of the conversation until now and given the state of the silos. Now, this is on top what you see here. This is the interface that we use for annotation, for labeling. So there was the piece of information, not so much. I'm going there because there's a typo. They have outdoor seating and social distancing, no clubs for now. So this is something that we got from this initial self-chat phase, and then asked others to annotate. And then they could pick a label, and here they chose what and submitted and went on. So this is how we obtained our labels. And then we used a machine learning system that essentially every piece of information was then classified into one of these slots. So we had not an answer, we had what, where, when, who, why, how, and greetings and formalities. Now, the reason why we merged them had to do with performance, but that's not the core issue of our system. But I'm happy to take any questions if you have them about this. Now, let me now try, this is the scary part, a demo here with our live system, so you can see what it looks like. So here, this is the system. Let me reload this. The interface, it will look like, or it does look like. And here are the questions. Please tell me what the first thing is you'll do when the pandemic is over. Now, I can answer something now. You will see that the system is pretty good, but it does make mistakes, right? We're in the very first stages here. Now, I could say, I'll go on holiday. Next question was, what has changed for you since the pandemic? Might not be that good of a question here, but let's go on and say, I can't meet with friends that much. Is there a particular place you want to go? So now it refers back to the holiday. I could say the Netherlands. Why Canada? So you see, it sometimes gets it wrong, and we'll come back to why it does that in a second. Now let me continue with because we don't want to spend too much time with it. Now this is this interface. You can try it if you want to have a look at this. Okay, so feedback learning style, second part of our development of this system. So we had this system, but we then were interested in, well, are the questions any good, right? Because we knew the system will make mistakes, as you saw now. Sometimes the questions don't really make sense. So we conducted what we call feedback studies. To cut it short, every time a question popped up, the participants saw this. So this was the flow of the chat, and then this popped up. Is this question, where will you go on your holiday, meaningful in the current context? And then I had yes or no. And from that, we could then say, okay, if this was a useful question, given a certain flow of the conversation, we would include it into the database. If not, we would just get rid of it. So the findings here, I'll keep this short because I want to go to the deception part. But essentially, this led us to 6,000 new conversation Q&A pairs that were just judged as really useful, and we could include them into our database. Now, this was all, again, no deception here involved at all. This was just to develop a system that can ask questions. Now, then we had a next set of studies, which we call the quality studies, because we wanted to know how good is the system. So how do participants perceive this? How do they like this? And to test this, what we did is we had random assignment. Participants either got a chat with 10 questions, with 20 questions, or with 30 questions in duration. And then we asked them a set of quality questions. So these were the overall conversation quality, the system skill during the interview, and they are adopted from cognitive interviewing. Now, given time, I'll make this very quick here because I really want to go to the deception part. Now, long story short here, the users found the shortest chat version as having the best quality and being the most pleasant, because apparently there could be some repetition going on if you keep the chat longer than that. Now about the deception study, and you will have access to the slides, of course, if you want to see the others. Now, how does this chat then fare against this full statement idea, where you just ask people to write a full statement and do this all online? Now, we had a study, and people were in a 2x2 design first randomly allocated to either the chat or the full statement condition, and then had either one to tell the truth or to lie about their plans after the pandemic is over. Now, the lies were self-chosen, which I'll come back to at the end of this talk as a problematic issue or potential limitation. Now, and what we want to know is how much information do we gain in either mode of eliciting statements? And then what about different decision-making models? So what if we do automated decision-making, so machine learning classification, or if we ask humans to read the statements and to read the chat protocols and then make a judgment? Now, the information gain can be summarized very, very briefly in that we don't really see a difference here, right? There is not really a big noticeable difference in, for example, that more named entities or reference to places, locations pop up in the chat compared to the full statement. So we don't really see a difference in this here. Now, talking about the classification, then we used machine learning. Very brief summary. So you have a full data set, you cut it into a training data set, and then evaluate it independently in a test training data set, do it iteratively a couple of times. We did this. Now, none of the models that we used here performed above the chance level. And now the more interesting part, and we're really at the sort of first stage only with this chat. Now, we then asked humans to read the statement. So humans got to read either the chat protocol or the full statement of that we elicit in this deception study, where people lied or told the truth about post-corona plans. And we did this in two ways. So one is we did the direct route. So we asked, is this deceptive or truthful? And the other one is this the indirect or heuristics-based approach. And this is what Bruno Verschurer talked about, where you just do this through the back door. So you say, well, how specific is this? So you're not even mentioning deception. You just ask, how specific is this? And use this sort of as a proxy for deception. These were the two routes. Each judgment was judged at least 3 times. And they made either a deceptive versus truthful judgment on a scale, or a vague to specific judgment on a scale. This is what this looked like. They saw the chat protocol in this case, or the full statement, and then decided in this interface. Now, here are 2 examples. Given time, we can't do this. Otherwise, I would have asked you which one is the deceptive one and which one isn't. Well, you could do this when you rewatch the video if you want to. Same here. But here are the findings. So direct decision making, we asked them, is this deceptive or not? What we find is, let's only focus here for sake of brevity on accuracy and area under the curve on the right-hand side in blue. If you give them the full statement, they perform at chance level, right? The chance level here was 50%. If you give them the chat, they can do slightly better. So they are at 60% accuracy. Now, even more surprising, if you give them the chat protocol, if you give them the backdoor instruction, so you say, how specific or how vague is this? Then they're again at the chance level if you give them the full statement, but they perform at 77% accuracy if you give them the chat. So something seems to be in this chat that they seem to pick up, especially if you use this heuristics-based approach. Now, to wrap it up, there seems to be this information advantage for the chat. It might be that just not picked up by the classifier, although we have to admit for proper machine learning, it's very little data that we have. But the humans seem to find this. So the humans seem to be able to make use of the chat information, especially if you give them the specific versus vague dimension to judge on. Now the chat seems to be useful, right? So it seems to, this very first stage, it seems to work that it elicits information rather than just passively waiting for it. And we have been able to sort of meet these requirements of having adaptive, dynamic, active, and calibrated system. Now, last slide, limitations and issues with this. Without spending too much time on it, because I still want to listen to Vero's talk, of course. Motivation differences, we saw them. So liars were more motivated to be coming from truth tellers, is of course potential confound. And we had self-chosen lies. So, and many of them were actually half lies. So this may have been this embedded lies issue. To have a look at this table here with true activity and the chosen lie. So we asked them, what's the true activity that you'll do? And then what is the activity that you chose to lie for people who were in the deceptive condition? And then you see, for example, one person had planned to go to London, but used as the lie, planning to go to Edinburgh. And you say, well, this you could do a lot of embedding there when you lie. So it's not really a full lie. Now, we have ongoing work. So we have already run this for past events. All data will be released that we do here. We have a few thousand conversations that we have here. And that was a joint work with Maximilian. If you have any questions for us, ask them now or let me know via email. Thanks.